everyone, welcome to the talk. You stole most of my lines, so I'm going to skip it. But yeah, I'm Sayali. This is my colleague Peter. We are going to be talking about Grokking OpenSearch build, test, and release infrastructure. As most of you already know, OpenSearch build, test, and release infrastructure has come from a long way. We started with Open Distro for Elasticsearch, which was grabbing the source code and the license to Elasticsearch and bundling a bunch of plugins on top of that. But today, OpenSearch has its old build, test, and release infrastructure. Let's go over the agenda. I know like this topic is really vast. It's a really vast infrastructure. So we are going to try our best not to put you to sleep for next 40 minutes, given the fact that this is after lunch session. So yeah, it's a challenge. So yeah, we will be mostly talking about building, testing, and releasing OpenSearch distribution. When I say OpenSearch distribution, it's basically OpenSearch and OpenSearch Dashboards core engine. And as of today, we have 20 plus plugins of each of those products. We build them, we test them, and then we release them to the community. We will also be discussing releasing these standalone components. Standalone components are those whose lifecycle is not connected to OpenSearch in like completely. They are dependent on OpenSearch in terms of APIs and stuff, but they live on their own, they release on their own, they have their own versioning. They do have the compatibility matrix with the OpenSearch as a product, but yeah, like they have their own life cycle. So the release process for them differs very much differently than the distribution. So we will be discussing and going over how we made it universal in such a way that any product who of any language, of any platform can release today under OpenSearch project. Like OpenSearch has a uniform build system like Gradle. OpenSearch Dashboards has Yarn or Node.js, and it's pretty uniform for all the plugins to integrate with them. When it comes to standalone components, each of them have their own languages, own platform. Like we have OpenSearch PHP, we have OpenSearch JS, JavaScript, OpenSearch Java as well, who release on Maven, who release on NPM. So there's no particular platform. They have very diverse platforms. So yeah, we will be talking about that. We will also be discussing the upcoming enhancements that we have planned that are on our roadmap. And finally, we will be having some time for question and answers. So requesting you guys to hold on to the questions till the end. I know there's going to be a lot of them. Yeah. So with that, we will be starting with building OpenSearch distribution and handing over to Peter.
Yeah, thanks, Ali. So let's talk about OpenSearch distributions. So what is a distribution to start with? A distribution, if we talk about the OpenSearch project in particular, is basically a bundled artifact that bundle both the OpenSearch core search engine as well as all its corresponding plugins together into a final artifact for release. There's also another distribution called the minimal distribution, which doesn't have any plugins. So it doesn't matter which distribution you are using, which we provide both. It has to go through several different types of processes in order to get it done. So they are namely the build process, the Xambu process, the test process, as well as the release process. So let's go into the first one, which is the build process. So build process, as the name suggests, is really just build or compile your source code, your assets, or your libraries together into some sort of artifact, and then it will be able to contribute later to a final distribution. And in order to do so, we need to feed some information to this build process, enable for it to know what kind of component you want to build, how to build them, and what order you want to build them. So there we introduce a concept of the manifest. Manifest is the core of the entire distribution. We use manifest as some sort of like a configuration file to contain the information related to this build as well as its components. So as you can see in this example, we have the name of the product, which is OpenSearch. If you're a dashboard, you'll put OpenSearch dashboard there. The version is 2.10.0, which we just released a few days ago. And the components is really the meat of this that has 3 of them over here. Of course, the plugin A and plugin B is just examples. You can put more plugins. The first one is always going to be OpenSearch core because that's the base of everything. Under each component, you'll have like multiple fields. I just took 3 of them as example. You have the GitHub repository URL, so you'll be able to find the source code. You have the commit ID, so you know the reference of this source code you want to pull. So for example, version 2.10, then you want to pull the 2.10 branch in order to build the code correctly. You have the platform, so let's say you support Linux and Windows, you're going to put both of them there. Once we have all this information ready, we feed it into the build code. And the build code will start by the ordering of these components. So the first one is the OpenSearch core, you'll always build first. We do it by first pulling the core repo source code and then run a build script, particularly to this repository on top of it. This build script, you can just think of it as a simple shell script that it only has, like, for example, because this is OpenSearch, it's Gradle based, it will run a Gradle task that is distribution, for example, Linux, tar, because you want to build a tar distribution. So you run that Gradle task and it will provide you with a core artifact. Now, this artifact will also be in tar GZ format because you specify the task to be tarball. But let's say if you want to build Debian and RPM, you can just run different Gradle tasks and the core artifact will be in different format. Now, if you don't need any plugins, you just need the OpenSearch core. That's it. And this is exactly the artifact you're going to get from the OpenSearch org download page. But let's say you want to use more plugins, and that's where the second step coming up. You pull the plugin A repositories, you run its corresponding build script, and then you get a plugin A artifact. Now, the reason I put plugin A zip over there is because all the plugins, doesn't matter, you build for Debian or you build for RPM or tarball, because they're Java-based, is always going to be a zip file. Going on, you have plugin B and so on, and just keep going, and then you have a plugin B zip as well. Now you have all your artifacts ready. The next step is the build workflow. The build code will generate a second manifest called the build manifest. This manifest is very similar to the input manifest we use over there. The difference is it now contains all the actual paths on the disk leading to the artifact you just built. So it knows where these artifacts are located. Then it can be fed into the next process, which is the assemble process for the next step. Now I want to mention one more thing is that we currently having tarball, tar distribution, RPM, Debian, Windows zip, and so on. But if there's any distribution that a community want to add into that, we encourage you to go to our OpenSearch org website and searching for a blog called Adding New Distributions in OpenSearch Project. It has detailed all the information on technical aspect on how you can actually working on our OpenSearch build repository in order to add more distribution to it. Now let's go to the next step. We build the artifacts. We have all the artifacts ready. We now need to assemble it. Why do we call it assemble? Because you have this separated artifact everywhere. It's in a folder. It's not a final bundle. So we want to bundle them. We want to assemble them. It's very similar to the build process, but the difference is we don't use the input manifest anymore. We use the build manifest that we just generated. Remember I tell you that it has all the paths leading to those artifacts? That's where we use it. So we feed this code into assemble code, and then we are able to find out where that core artifact we just built located. We'll grab that, we extract that artifact, and then we'll grab these plugin zips we also created, and we run a installation command on the core artifact. So for example, if it's OpenSearch, then it's bin/OpenSearch plugin install to install this plugin we just built. Now, after we finish that, the assemble code will then generate a third manifest, which is called the distribution manifest. On the surface, this distribution manifest has nothing different from the build manifest. On the high level, of course, in the details, there are a lot of difference, but the idea that it calls the distribution manifest because it's going to be the end product of the distribution. It will be part of the distribution bundle. We now have everything ready. We run the final step, which is to actually make the distribution bundle artifact. So if it's a tarball, it will just run tar cvf and just create the tarball. And if it's Debian, it will run debmake. If it's RPM, it will run RPM build, and zip will run in zip, and so on. And there it is, your distribution bundle artifact that we're going to put it onto the OpenSearch org website for you to download. So we have finished the build, we finished the assemble. Can we just release it? I guess we still need to test it, right? Because that gives us more confidence on the product that people will say, this has been thoroughly tested. We believe this product it's very well made and it doesn't have the issues. So we introduce you two types of different tests, which is integration test, we call it intact test, as well as backward compatibility test, which we call BWC test. You might ask, like, isn't that all of the repositories or the components we pull from to make this build already have like test cases in there with their source code? You will run those GitHub checks before you commit a change in your PR, right? So the integration test is already done. Why do we need another integration test? The reason being that if it's singular, like individual repositories, their test is only focused on their own plugins with nothing else. Like there's no other plugins together. With our case, we brought the bundle we just built in the assemble process, deploy into a server, make it a cluster, which has all the plugins side by side, and then run the intact test one by one. This will ensure us to make sure there's no regressions or any side effects between all these plugins. As for the backward compatibility test, we really just want to make sure that we don't introduce any incompatible changes between versions, and so that especially the minor version and the patch version, so that we are following the SAMR guidelines. And you can see the flow down there is basically test manifest, going to deploy that bundle, running the test, and then generate the test report. It's the same or similar for these two tests we're mentioning here. Now let's go to the performance test. The reason we put it by itself, because performance, everybody cares about performance. We want to know if there's any latency regressions or any, let's say, throughput regressions on our queries. So we have this OpenSearch benchmark tool that is basically a macro benchmarking framework for OpenSearch. And we fork it from ESReally, and currently it's available from the on the Docker Hub, ECR or PyPFO to grab. The flow is very simple. How do you use this tool to test your OpenSearch cluster performance? You get the user, grab the binary of OpenSearch benchmark, deploy to a host, which we call the benchmark host, alongside with all of its workloads. And then we grab the bundle we just built, deploy it into an OpenSearch cluster, and just generating load, running the test against it. Once the test is finished, the OpenSearch benchmark tool will just generate a summary report for you in the text format. And if you want to re-ingest those data of those reports into an OpenSearch cluster, another OpenSearch cluster for you to be able to analyze those results, you can also do so, which we support right now. And that just comes back to exactly what we are doing right now in OpenSearch project. We are doing nightly runs of all the versions that we are currently running, which is the current version. For example, 2.10, we just released a few days ago. Next version, 2.11, which is upcoming. And future major release, that it will be like, for example, 3.0, that at the time of this talk. We're running all of these tests every day, daily, and then we ingest all of this data into our other OpenSearch cluster to analyze them, and then show you guys on our OpenSearch benchmark website on opensearch.org/benchmarks. It has all the infos every day, all the data. So if there's any regression that we find out between yesterday and today, we can immediately figure out what commit caused it. So we revert that commit, or we just fix that bug. And the workload, currently we're running NYC taxis and HTTP logs, which is corresponding to the search performance as well as the log analytics performance. So yeah, now you build your artifact, you assemble your bundle, you test this bundle and make sure there's nothing wrong. And then the next step is to release it. So I'll pass back to Sayali to go forward that.
Thanks, Peter. That was a lot of information, I'm pretty sure. It takes a lot of time for us to onboard to this as well if someone new comes up. But yeah, now like you have built your product, you have tested it. Now it's the wake-up call, like to release it. So let's go over the release process. Like as I stated before, we will be discussing the distribution release process. Whatever Peter just built and tested, that comes under the distribution release process. For standalone, it's a different process. I would also like to mention that whatever we build and test, we have the container images available so that you don't have to deal with setting up your laptop to the right version of Python, to the right version of Java that needs to be used for that particular version of OpenSearch and OpenSearch dashboards. So we have the manifest includes the whatever manifest we input, it does include the CI images. It's called as CI images. So those images can be used on your local so that you don't have to set up your own infrastructure. Those comes pre-bundled. You just have to go and run the commands that you want to generate the distribution for. And that applies to both OpenSearch and OpenSearch dashboards. So let's go over the distribution release process. I believe most of like many people sitting here with a part of the release that we recently did on Monday, like 2.10.0. It was pretty hectic as usual, but yeah. So let's go over the process. We start with declaring the dates. We usually do this by putting up the dates on our website. You can go and search under opensearch.org/releases. We usually declare the code freeze and the release date. That's what we start with. So you know when your code needs to get in and at what date we would be releasing. That was the model that we used to follow earlier. I'm going to go over the new model as well. Next, we start with the preparation phase. Preparation usually includes creating the component release issues and the main release issue. You would also find the dates to those releases in OpenSearch build repository, which we have an automation in place which automatically detects that OpenSearch has incremented the version and okay, a new release is likely possible. So it goes and creates a GitHub issue for us. We also have an automation in place to create the subsequent component issues. All the components that are going to be a part of that release, usually a new component gets added in a new minor release. But yeah, like we do have the automation in place to go and create the release issues in their repositories as well. So that helps with the components as well to alert them, okay, a new release is coming up and we need to assign someone to go over all the tasks that has to be done. We also assign a release manager at one level. Like I was the release manager for 2.10. So my responsibilities include coordinating between the multiple teams, coordinating between the documentation, blogs, and everything, and making sure we agreed and good to go. Next, we have a code complete date or code freeze date, where by the time we need to ensure that all the features and all the code is completed by that time, and nothing gets left behind or a commit is missed. We need to make sure of that. We have release branch readiness as the next step. Release branch readiness usually includes creating a release branch. Like for example, for 2.10.0, the release branch would be 2.10. We need to make this is to ensure that we are ready for the upcoming release and the active development goes on for other versions. For example, the 2.x, while the 2.10 was going on, was pointing to 2.11. So you don't, for the features that were not able to be shipped as a part of 2.10, the active development continues. It's a normal software process, but we need to make sure that whatever branch is being a part of this release is ready for the release. Next is the release candidate creation, which whatever process Peter just explained, we build them continuously. We also have the automation in place, like if a particular component fails, we create a GitHub issue with them, pinging them, okay, hey, your component is broken for this version, something needs to be fixed. So please go ahead and fix it. We also give them the reproducing steps, like go ahead and like these are the commands, run it, see what you're missing. We then move to testing, which, as Peter explained, includes integration, VWC, performance, everything at the distribution level. So it might look all pretty at the repo level, but when the integration test or VWC tests run at the distribution level, there might be some conflicts. For example, the security plugin is causing issues for you because the test needs to be fixed or there's an actual issue with your plugin. So you need to go and fix those. We keep on testing and then we keep on generating the release candidate until we have a viable one. And finally, we do a release. So yay for everyone. We have a go no go call, which is a part of the release where all of the all of the components, we take an opinion of them if they have any blockers. If they saw anything that would block a release, we check with everyone if the release block was ready or if all of the components or all of the documentation PRs that were in review have then been merged, because you just can't release and not tell the community how to use it. So it's important for us to get those in as well. So that's one of the critical criteria. And then we promote and then we create tags for them as well. So for all of this, we have the automation in place as of now. It was a really bad process before when we started. I remember for 1.0, it was just few shell scripts and few Python scripts, and we were just running it manually. We have come a long way from there, and we are still far away from where we want to be. But yeah, this is the process, and the entire cycle repeats for the next release. This is all about the distribution release cycle that we have. Okay, now the problem with those cycles, like every process is different, every process has its pros and cons. We had to. This model that we followed was date driven. We used to declare the code freeze, we used to declare the release date, and we used to chase them. It was pretty stressful. Being a release manager for few past releases, it was way too stressful for the release manager as well as the component teams. Like, you have to fix this within the next 2 days because we are releasing after 3 days. And yeah, like extended working hours, and it was way too stressful. So we were like, okay, this is not working for us. Few of the side effects that we faced in the past was moving the code freeze date, because okay, we contributed the feature, but while testing we received a huge bug that needs to be fixed, which was not good. Also, we did not get enough time to test, so we wanted to make sure that everyone has ample amount of time to test at their own pace, to have enough time to analyze what they have contributed, and also have certain security, like all the certain checks and documentation and everything in. Introducing the new model that started in 2.10 was a window model. Release window model was less stressful. I'm not saying releases are not stressful, they're always stressful. But yeah, like window model gave a buffer to us to start with how a release should look like. We have certain entrance criteria that we want to meet. A few of the entrance criteria where the code coverage is not decreased, your documentation PRs are up in the review, and also like these are the few of the entrance criteria on the top of my head. Also, yeah, your integration tests are running well and everything. Next, we used to build and test. These are the nightlies. We used to build and test daily, generate the release candidate daily until we have a viable one. So when do we say a release candidate is viable? That's where we have exit criteria. So the exit criteria was the integration tests are passing at the distribution level. Hello flaky test that we saw this time. You can go and see the retrospective issue for 2.10. But yeah, we figured out there were a lot of flaky tests. That those is not actually the issue with the plugins, but actually the issue with the tests that were written. So we went ahead and tried to fix them. If they were not fixing them, they were a blocker for the release. So we removed a few of them and made an issue to ensure they are fixed by the next release. So these are the few of the exit criteria that were met. All the documentation PRs are up, the release blog is ready, and we have a go from everyone. So those are some exit criteria that we met. Once the exit criteria was met, we were good for release. We got a go ahead from everyone. And once we said we are ready, we will release within 2 days. So how to make sure that this doesn't go on and on, like, for like a month or two? We enclosed all the entire process in 2 weeks. So if the release window, at the start of the release window, we declare, okay, we are starting the release window and the deadline is 2 weeks. If this release window, if we are not able to meet the within this release window, we will just close the window and start a new one. That may be after a few weeks, after a few months, but this particular release window will be closing. This model helped us to figure, like, essentially there was an endpoint, like there was an exit criteria, everything needs to be green. We got a good checklist to meet before we release something. And also, like as I said, like it was less stressful, like you have some buffer so that you can work at your own pace and do the things right rather than just doing it. So all of this is about distribution release process. 2.10 was the first candidate, by the way, to follow this. We will be coming up with more, like all the next releases will be following those. We will be adding more entrance criteria and more exit criteria as we learn. So yeah, that's pretty much it. Next, we are going to go over the standalone release processes. I explained before what the standalone components mean, like they're self-contained, they are diverse. And these are the few examples that we have for standalone components. The process for releasing the standalone components was a bit critical. Everyone has their own style of building, their own build tool and their own testing. So we want to make sure that when we release something on our infrastructure, the artifact should not differ from what the developers were building. regularly. So the change in build environment, like the packages that were being installed on our release platform, should not be different than what they have. Signing system, signing the artifact was one of the huge challenges. The reason being, the signing system for OpenSearch is a bit complicated. We are yet to open source it, but at the current situation, we require a lot of authentication and that needs to be set in place, and that needs to be used. So the signing system entirely, like using it for each and every component under OpenSearch project with their own own GitHub repository, it was a bit complicated. So that is one of the challenge that we faced. Also, how do you control the access to the credentials? Like 10 people release on Maven, 2 people release on NPM. We have like almost 100 plus repositories under OpenSearch product. How would we know who is using what? And how do we control who is using what? Me and my team, we were the few people who were responsible for handling those credentials, and we became bottlenecks for them. Like releases were only possible only if we were available. If we are not in between other releases, or when we have time, only then we would be able to help you with the releases, which was not sustainable. Looking at the size of OpenSearch project that it is growing, I believe like today, as of today, we have like 20 plus standalone components, and just imagine 5 of them want to release on the same day. I mean, we would have to work more than 10 hours for that. And following a set of documented process again and again, it was not sustainable at all and very much prone to human error. So we came with one of the approach. I'm not saying this is the best approach. Of course, there are many more good approaches ahead, and we are welcome for the suggestions and feedback. The approach we followed had a certain centralized CI/CD system. When we say CI/CD, we only use the system to release those products with few exceptions, but most of the standalone components today only use the centralized CI/CD system to release them. So all the standalone components would need to do is build it, test it, and give it to us. We won't be building and testing it for you, looking at the number of products that we have. Just build it, whatever you use, like GitHub Actions or whatever, Travis CI, Jenkins, whatever. Just build it, give it to us. We will sign them and release them. That's all we are going to handle. We also made sure that the release process we do for standalone includes a 2% review. Like not just one maintainer is responsible for entire release, but we have multiple people reviewing what that one maintainer is doing. And finally, we also wanted to make sure there is minimal human intervention, mostly because we wanted to get out of the coming to us and we being the bottlenecks, but also less stressful for maintainers to just go and see, to go and click a few buttons. So this is a sequence diagram for the standalone release process. These are the components that are involved today. GitHub, which is the heart of OpenSearch project, being the open source. We tried to use as much components of GitHub as possible because we didn't want to over-engineer what is already available. So we used GitHub as much as possible. We have Jenkins as one of our CI systems. You can look at them at build.ci.opensearch.org, and all the workflows run on them. We have the signing system, and only Jenkins in this case has access to the signing system, no one else. So it makes sure that all the credentials and all the signing that is being done is secure and limited to very few people. And finally, the final destination of those artifacts that are NPM, Maven, or etc. So how does this work? We start with maintainer pushing a tag to the GitHub repository. Once a maintainer pushes a tag to the GitHub repository, it triggers a release drafter workflow. So GitHub, you might know that GitHub Actions are responsible to run any workflow, any kind of workflow that you want. GitHub draft releases are a great way to host your artifacts as well. So we used that to hold the artifacts that we want to release. Instead of creating a completely different infrastructure or storage system like S3 or Google Drive or something, we use GitHub draft releases as our interim storage. So as to wherever possible. Until now, I don't think we have any saying that that's been a problem or the GitHub's draft release does not handle our artifact well. But as of today, we are using that. Next, when a user triggers a release and it triggers the release drafter workflow, it creates an approval request just to give a heads up and get an approval from other maintainers or code owners of that repository asking for their approval. When it sends an approval request, it is requested from all the maintainers by creating a GitHub issue. So all the maintainers, like except the one who initiated the release, they can go and do a second check, like does it have the right tag, does it have the right commit to go ahead. And once that approval is received, the workflow continues. Once the workflow is continuing and it builds the artifact and creates a draft release, the draft release includes all the release notes for that particular release along with the artifacts. And finally, GitHub also has a good webhooks level. If the GitHub is down, that's a completely different issue. We have been victims to that. But yeah, like if the GitHub is down, you won't even be able to push a tag. But yeah, like there have been some issues with the webhook, but they have pretty good payload, and they give pretty much all the information that is needed to create a release or to make a release, or from where that webhook was generated, using what releases and what artifacts are attached. So it's a pretty good way. We reuse that, and it sends a trigger to the Jenkins, which has its own workflow. So each of the components today under OpenSearch project that are standalone have their own Jenkins workflow. So they have control over how they want to release it, where they want to release, and at what pace. So none of the two of them would ever interfere with each other. We are trying to make it more generic, but as of today, they have, like, each of them are secluded. And finally, we download these artifacts, we sign them and release them to the final destination, like it's NPM, Maven, Docker Hub, etc. After that, once the release is successful, we also have a mechanism in place to publish that release on GitHub. So whatever was drafted on the previous stage, we will release it on GitHub, informing the user that, okay, we have finally published and the release was successful. We like to call this process as one click because it's just pushing a tag, well, apart from other maintainers approving it. But the entire flow, we like to call it as one click release process workflow. We would like to implement a similar structure for OpenSearch project as well, the distribution release process as well, where we just push a tag or just click one thing and it releases to all the platforms. Right now, it includes multiple distributions and multiple workflows, and we do a bunch of clicks. Even though it's automated, we want to make it in a one click as well. So of course, we welcome the contributions, and we are looking forward to make that process as one click as well. But at least for standalone, we have this in place. As of today, we have 20 plus components who have been automated, and there are more and more coming up. So that was a win for us, like going from 2 hours of running manual scripts to just reducing it to 10 to 15 minutes. It was a huge win in terms of operations. Finally, we have the upcoming enhancements that we are planning for OpenSearch project, starting with incremental builds. Like whatever builds we have today, they are pretty sequential in the sense, like if a particular build fails, or if something, only one plugin fails out of 20, we rebuild the entire thing again. That takes almost like 1 hour extra. We are trying to introduce incremental builds where given, many of you would be having the information of how Gradle does it. It detects the delta and it just builds on top of it. We want to do a similar thing for OpenSearch and OpenSearch dashboards at distribution level. If we already have the artifacts pre-built, or we have some of the artifacts pre-built, we want to grab those and only rebuild what has been failing or what is causing issues. We also want to decouple the distribution builds. If any of you have went and saw the distribution workflow today, it's pretty clunky. It's like, even though it's a Jenkins workflow, it's a huge, like it's almost 1,000 lines of code, and it's pretty difficult to maintain because all the distributions are present in one workflow. So we want to decouple those into its own, like we want to keep RPM different, Debian different, so that each of them, they are easy to maintain, and also don't depend each other in any way. We are coming up with new distribution support for macOS. There has been a huge request, and we are trying to get this on plate. But before we introduce something new, we want to perfect what we have. So we are trying to enhance our build system properly before we introduce new distributions, being one of them being macOS. And finally, better performance testing with various workloads. Right now, we are only testing with NYC taxis and HTTP logs. We do have various workloads available, but we want to make the performance testing better and robust so that we can generate use multiple workloads. We are also trying to introduce the performance testing for plugins. Like right now, it's only core and the entire distribution that is tested, but we also want to add the performance testing at the plugin level. And finally, we want to have a multi-platform automated integration testing. Huge kudos to Peter, who recently added the containerization for Windows. So like Windows is always a pain, like right from building, testing, and including releasing. So currently we added, like we had the automated testing for other platforms except Windows, but just before 2.10, we introduced the containerization of Windows. So right now, just take the container and do the testing on top of it, which already has all the packages installed. So we don't need to go and install huge like other different packages. So that helped us to run the integration testing more often and catch issues. So yeah, like along with adding new distribution support, we also want to add multi-platform integration testing support as well. And that's pretty much it. Thank you.